Hi there, in this video we are going to solve real-world problems using inequalities. Alright, so for starters I have a few keywords up here that we really need to know. So we have less than and fewer than. We use this symbol to show that. So less than, fewer than, that's the less than symbol. Next we have greater than, more than, or exceed. So we use the greater than symbol. And then we have less than or equal to, at most, no more than, a maximum. So that's less than or equal to. We use this symbol. And then we have greater than or equal to, at least, no less than, and a minimum. So that's more than, greater than, or equal to. So those are the four symbols that we use, and these are the key words. A lot of the ones that confuse people are at most, no more than, or a maximum, at least, no less than, and minimum. So you need at least $100 to go to the fair. That means that you need $100 and more money to go to the fair. Those shoes will cost at most $200. Okay, that means that they might cost $200 or they might cost less than $200, but they won't cost more than $200. So that's when you would use like at most. All right. So let's look at example 1 here. We have Matilda needs at least $112 to buy a new dress. She has already saved $40. She earns $9 an hour babysitting. Write and solve an inequality to find out how many hours she will need to babysit to buy the dress. So we're going to say let x equal how many hours she will need to babysit. So we're going to say the number of hours. Number of hours she needs to babysit. All right, so our inequality is, we're going to start off with this where it says at least $112. Well, at least is here in our keywords. So we're going to use the greater than or equal to symbol, greater than or equal to $112. She already saved $40, so we have $40 here, already saved. And then she earns $9 an hour, so she's earning $9 per hour, so plus 9x. Because we said that x over here is a number of hours. Okay, and now we can go ahead and start solving. So we're going to start off with the constant. The constant is 40. We're going to do the opposite, which is minus 40 on both sides. So we have 112 minus 40, and we get 72. And now we're going to divide each side by 9, and then you get x is greater than or equal to 8. So here, where it says interpretation, if somebody asks how many hours will I need to babysit, you wouldn't answer them as, oh, x is greater than or equal to 8. That doesn't make sense. You have to answer the question that's being asked. So the question that's being asked is how many hours will she need to babysit? So she'll need to babysit. She'll need to babysit. You can say at least 8 hours. You could say 8 hours or more. You could say no less than. Anything that's in this box you could say in your interpretation sentence. All right, next. Tamika already has $55 in her savings account. If she puts $5 per week in her account, write and solve an inequality to find out how many weeks she must save to have a minimum of $100 in her account. And then interpret the solution. So we are finding how many weeks she must save. So let x equal the number of weeks. Our inequality, we're going to start with Tamika has $55 in her account, so we're starting with $55. Then she puts $5 per week, so she's adding $5 each week, and we said the number of weeks already is x. And we are trying to find how many weeks it'll be for her to have a minimum of $100. So minimum, if I go back up to my keywords, hold on. If I go back up to my keywords, minimum would have been the last column, which is greater than or equal to. So we're going to use greater than or equal to as the inequality here. Sorry, I just want to make sure. There we go. So minimum of $100. That means that she wants $100 or she wants more than $100. So greater than or equal to $100. Okay, and then we can go ahead and solve. So we're going to subtract 55 on both sides. Then we have 5x is greater than or equal to 45. Then we are going to divide each side by 5, and that's when you get x is greater than or equal to 9. So our interpretation sentence here is she must save for a minimum of 9 weeks. You could say at least 9 weeks. You could say 9 weeks or more. Any of those work. All right, number 3, you want to spend at least $12 on a carriage ride. The driver tells you there is an initial charge of $5 plus 50 cents per mile. Write and solve an inequality to find out how many miles you can go on the carriage ride and then interpret the solution. So here we're going to say let x equal the number of miles. All right, you want to spend at most $12. So that means that you want to spend $12 or less than that. So you'll have the less than or equal to symbol. You don't want to spend $13 or $14, $15. So that's why whatever we're spending has to be less than or equal to. So we're using that symbol, less than or equal to $12. All right, the driver tells you the initial charge is $5. So we're starting with $5 plus 50 cents per mile. So I'm going to do plus 0.50 cents per mile. So plus 0.50x. And now we can go ahead and solve. So I'm going to start with subtracting 5 on both sides. Okay, and then we have 0.50x is less than or equal to 12 minus 5, which is 7. Then we are going to divide each side by 0.50. And we get x is less than or equal to 14. So you can go on the carriage ride for, you can go on the carriage ride for at most 14 miles. You could say a maximum of 14 miles, no more than 14 miles. Any of those would work for your interpretation sentence. All right, number 4, Latrell has $8 to spend on postcards. He wants to buy one large postcard and some small ones. Large postcards cost $2 each. Small ones cost $1.25. Each. Write and solve an inequality to find out how many small postcards Latrell can purchase and then interpret the solution. So we're going to start off with let x equal the number of small postcards because that's what we're looking for. Okay, he has $8 to spend. Oh, sorry. We're not going to start off with 8. So he has $8 to spend on the postcards. Large postcards cost $2 each, and we know he is buying one of those. Buy one large postcard, that's $2. And then he has small ones, or he wants small ones, and those cost $1.25 each, but we don't know how many small postcards he wants, right? So small ones cost $1.25, and you are finding how many small ones that he's going to buy. So we're going to say plus 125x. And then we are trying to figure out how many of the postcards he can buy. So even though this question doesn't actually have any of the key words that I started with at the top, it does give you enough information to figure out what symbol to put here. So if you notice, it says Latrell has $8 to spend on postcards. That means he can spend $8. He could spend $7. He could spend $6, right? So he can spend $8 or less, but he can't spend $9, $10, $11. So we are going to use a symbol less than or equal to 8, because whatever he spends has to be $8 or has to be less than $8, because all he has is $8 to spend. Okay, now we can start solving. So I'm going to subtract 2 on both sides here. Then we have 1.25x is less than or equal to 6. And then we are going to divide each side by 1.25. Okay, and then we have x is less than or equal to 6 divided by 1.25, which is 4.8. Go back and read the question, though. It says, how many small postcards can Latrell purchase? Well, he can't purchase 0.8 of a postcard, right? That doesn't work. He also can't round that up and say, well, I want to purchase 5 postcards, because it has to be less than or equal to 4.8. So in reality, Latrell can purchase no more than 4 small postcards. All right, so don't automatically look at this and round it up to be 5. He doesn't have enough money to buy 5 small postcards, right? Our answer that we got here is less than or equal to 4.8. So 5 is not less than or equal to 4.8. So this has to round down. So this is one of those that you really have to pay attention to the real world question that's being asked of you. Okay, Sylvia needs more than $310 for a new audio system. She has already saved $120. She earns $10 per hour at her part-time job. Write and solve an inequality to find how many hours she will need to work to buy the system. So how many hours she will need to work. So we're going to say let x equal the number of hours. All right, so she needs more than $310. So more than is greater than 310. She has already saved 120. So we're starting off our inequality with 120, right? Because that's already saved. And then she earns $10 per hour. So earns is plus $10 per hour. And hours, we already said over here, is x. Now we can start solving. So we're going to start with the constant. The constant is 120. We are going to do the opposite, which is minus 120. So 310 minus 120. These cancel out. You're left with 10x is greater than 310 minus 120, which is 190. Then you're going to divide each side by 10, and you get x is greater than 19. So here it says, how many hours will she need to work to buy the system? She will need to work more than 19 hours, because we got x is greater than 19. All right, I hope you learned how to use inequalities to solve word problems. Thank you for watching.